Assalamualaikum. Physics Form 4 Wave EBelajau. Our topics today is 5.3 Reflection of Light. I am Cikgu Suryati Yusof from Sekolah Menengah Sains Muzaffar Shah Melaka or MOZEC. Today we are going to talk about reflection of wave. Our standard learning today is first, describe reflection of wave from the following aspect. First, angle of incident I, angle of reflection R, wavelength lambda, frequency, speed and direction of propagation of wave. Second, you have to know how to draw a diagram to show the reflection of plane water wave by through a plane reflector. And third one, justify the application of reflection of wave in our daily life. Okay.
What can you see at the surface of the water? The surface of the water shows the reflection of the moon. What happens to waves when they are reflected? When you let out a shout in a canyon, what do you hear? Echoes can be heard. How are echoes produced?
The trick for these surfers was to catch the first wave and then transition, catch the original incoming wave and ride that back to shore. But a lot of them just kept getting wiped out by the double peak.
Now we move on to the first topic. So observe diagram below. What will happen to a seawater wave as it hits the shore or it hit the stone? Okay. So reflection of wave occurs when an incident wave strikes a hard surface and reflected. The surface acts as the reflector. Okay. So start with the definition of a wavefront. So what is meant by a wavefront? Okay. So wavefront is a line joining all points of the same phase. Line joining all points of the same phase. 2 points have same phase if both points have same displacement and move in the same direction. Molecules, the 4 particles will move outwards, will vibrate upwards. So they are in the same phase. So the line joining A, B, C, D is what we call wavefront. So when we see from the top, this is what we call plane wave. So this is example of plane wave. Okay. So the red line is what we call wavefront. So what can you say about direction of propagation of wave and the wavefronts? Okay. So the wavefront is in this direction. This is the propagation of the wave. So they are in perpendicular. So direction of propagation of wave is perpendicular to the wavefronts. What can you say about the direction of propagation of the circular wave? So this is a circular wave. Okay. This is the wavefront and it will move outwards, radially outwards. So the direction is radially outward, which is perpendicular to the wavefronts. Okay. Here is another video about wavefronts and the direction of propagation of wave. Okay, so this is the wavefront, the plane wave move in this direction. Okay, and this is the direction of the propagation of wave. So the wavefront in this direction, this is the direction, so they are in perpendicular. So let's look at the circular waves. So it will move radially. So the wavefront is perpendicular to the direction of the propagation of the wave. Okay. Okay, so look at the first activity. Show the direction of propagation of wave by using arrows. Okay, so here is the plane wave, so perpendicular. Here is the circular wave, which is radially outward and perpendicular. Okay, according to your observation, state the relationship between the change of wavefront with the direction of propagation of wave. So they are in perpendicular. Again, the wavefronts are perpendicular to direction of propagation of the wave. Okay. Now we are going to learn about ripple tank. Okay, so a ripple tank is used to observe the propagation of the water wave. Okay, so first we have to know how to explain how the dark and light fringe are formed on the screen. Dark and bright, sorry, this is how the dark and bright fringes are formed on the screen. So here is the ripple tank. Okay, and here is the view from the side way. Okay, so this is the water wave. Okay, so this is the ripple tank which have water, and the water is vibrate by using the vibrator. So this is the crest, and here is the crest also. Here is the crown. Okay, so water is transparent, so light can pass through the water. So that's why we have to use light ray, the bulb here, which produce light rays, and the light will pass through the water. So what happens is the water will act as what we call lens. Okay, so the convex lens. So the crest act as a convex lens, and the light here will pass through, and convex lens will diverge. Sorry, the convex lens will converge the light to a sharp point here, so they will produce a bright image. So the crest converge the light rays to form the bright line. Okay, next we have is the shape of throw act as a concave lens which diverge the light and will form a dark line here. So it will be alternate bright, dark, and so on. Okay. Now state the law of reflection. So the law of reflection said that the angle of incident equals to the angle of reflection, where I equals to R. So this is the incident wave. Okay, this is the direction of the incident wave. So this is the wavefront of the incident wave, the blue one, and the red one is the wavefront for the reflected wave. So this is the direction of the reflected wave. So here is the normal line, here is I, angle of incident, R is angle of incident. Sorry, I angle of incident, R angle of reflection. So incident wave, the wave before is strike the obstacle. Reflected wave is the wave which has undergone a change in direction or propagation after reflection. I is the angle of incident, and R is angle of reflection. Okay, so always remember the angle of incident or angle of reflection must in between the incident wave and also the normal line. Okay. Okay, so we have experiment 1. Observe the reflection of plain water wave in a ripple tank. Okay, this is a ripple tank. So this is a ripple tank. Set up the apparatus, switch on the motor, and increase the frequency of the wave by increasing the voltage power supply to the motor. Observe the reflected wave by using a stroboscope. Okay, this is what you will see. Okay, the plain wave. This is the barrier. So this is the reflected wave. Okay. Okay. So notice that the wavelength is all equal before and after reflection. Okay, now we have to draw the diagram of the reflected wave. So this is the step by step how to draw the reflected wave. First, you have to draw a straight line to represent the direction of propagation of the incident wave. So this is the direction of the incident wave. So this is the plane wave. Remember the wavefront. Remember the wavefront and the direction always perpendicular. And then you draw a normal line. So this is a normal line which is perpendicular to the plane reflector. And here is the we draw the line to show the reflected wave. So here is the incident angle, here is the reflected angle. Okay, and then we draw the wavefront of the reflected wave which is perpendicular to the direction of the reflected wave just now that we have drawn. Okay, now we draw a diagram to show a reflection of wave. So we label I and R. Okay, so the first one. So this is the direction of the reflected wave, and we draw the wavefront. Make sure that lambda 1 equals to lambda 2. So lambda 2 is the reflected wave. So lambda 1 equals to lambda 2. So this one we have the reflector at a certain angle. Okay. So we draw the normal line. Okay. And here is the incident direction of the reflected wave. And this is I, and here is VR, and we draw the wavefront. Make sure that the wavefront lambda 2 equals to lambda 1. And this is direction of the wave V1, before and after is V2, and make sure that V1 equals to V2 because the depth of the reflectance is the same. Now compare the angle of incident I and R. So we have I equals to R. The water wave with a wavelength lambda move towards a straight reflector. What is the wavelength of the reflected wave? So they should be equal. Okay, so lambda 1 equal lambda 2 equals to lambda. Now compare between incident wave and reflected wave in terms of speed before and after reflection. Speed unchanged because the depth is equal. Wavelength also unchanged. Frequency also unchanged because the same motor with the same frequency, but the direction will change. So this is the characteristic of the reflected wave. Okay, this is the effect of the wave. So it will erode the shore. Okay, so all back effect of the reflection of water wave. This is seawater wave, right? It's all caused by erosion, and we used to tanam what we call pokok bakau in order to reduce the erosion of the seashore. Okay, and we use venting. Okay, we use concrete in order to withstand the shore from erosion. Okay. It is also concrete barrier. Okay. It is processed to put in the barrier. Okay, now we move on to the application of the reflection of wave in daily life. Okay, name the reflected sound wave. This is what we call echo. Okay, list 3 types of sound wave with the range of the frequency. So we have 3 types of sound wave. First is ultrasonic wave, range is less than 20 Hz. Then we have normal audio sound, which is the sound that we can hear with our ears. So in between 20 Hz to 20,000 Hz. Here is the ultrasound. The third one is ultrasound. Range is more than 20,000 Hz. So very high frequency. Okay, diagram shows a sonar system is used to determine the depth of the seabed. A sonar system has a very high frequency. What is sonar? Sonar is a reflector ultrasonic wave. It is used to navigate, communicate with, or detect objects under the surface of the water. So this is a ship. This is a transmitter which emits ultrasonic wave. Then is reflected by the seabed and received by a receiver on the ship. State the sound wave phenomena to measure the depth of the seabed. Reflection. Explain why sonar use a high frequency sound, high energy, and it can move further. Explain how to measure the depth of the seabed. Okay, so we need to have a transmitter and a receiver. Okay, first the transmitter emits ultrasonic wave to the seabed. Then the ultrasonic wave is reflected by the seabed and is detected by a receiver. Time interval T for the ultrasonic wave to propagate to and fro from the seabed is measured. The depth of the seabed S is measured by equation S equal to Vt over 2, where V is the speed of ultrasonic wave in water. Okay, so from here what we measure is the time from the transmitter to the seabed and back to the receiver. But in order to find the distance, we need to have only time from here, from the transmitter to the seabed. That's why we have to divide by 2. Okay, the time taken for a pulse of ultrasonic wave to travel to and fro the seabed is 0.28 seconds. If the speed of sound in the water is 1,500 meters per second, calculate the depth of the seabed. So we use the formula. We collect all the given data. T equals 0.28 seconds. V equals to 1,500. So we have the formula S is equal to Vt over 2, 1,500 times 0.28 divided by 2, and we get 210 meter. Okay, explain why the speed of sound in water is higher than speed of sound in air. So water molecules are closer to each other, therefore sound energy can be transferred faster from one molecule to another molecules. Okay, application 4. Diagram shows a system to scan a fetus in a mother's womb. So what is the function of transmitter? So this is transmitter, this is the receiver or the detector. So transmitter transmit ultrasonic wave, and detector receive reflector ultrasonic wave from the fetus. Okay, this is a picture of the image you get from the ultrasonic system. Okay, explain how the fetus is scanned until an image is formed. Okay, so a jet is spread onto the mother's abdomen. The transmitter emits ultrasonic wave. The waves travel through the skin and are focused on the fetus. Ultrasonic bounces off dense water from dense surface, for example, bones and tissues, and received by the receiver. A computer analyzes the signal to form an image on a monitor screen.
The heart of most ultrasound systems is a device called a transducer, which uses an array of piezoelectric crystals. A piezoelectric crystal vibrates when an electric signal is applied, producing high-frequency sound pressure waves, which we call ultrasound. More importantly, this type of crystal can also work in reverse. It can produce electrical signals when it detects high-frequency sound pressure waves. When a transducer directs ultrasound waves into the body, they pass right through the skin and into the internal anatomy. As the waves encounter tissues with different characteristics and densities, they produce echoes that reflect back to the piezoelectric crystal. This happens more than 1,000 times a second. Returning echoes are converted to electric signals, which a computer converts into points of brightness on the image, corresponding to the anatomic position and the strength of the reflecting echoes. A medical transducer contains a large array of crystals, which allow it to make a series of image lines that, together, form a complete image frame, called a sonogram. In addition, all the crystals are repeatedly activated many times in such a way that a complete image frame is formed around 20 times per second, so that real-time motion is displayed in the ultrasound image.
Okay, so why ultrasonic wave is used instead of X-ray? Long periods of exposure to high-frequency radiation from X-ray can cause mutation in cells. This may cause abnormalities in newborn babies. Now we look at the application in the communication. Okay, what is the function of the parabolic antenna in the satellite communication? So this is the astro communication parabolic antennas. Okay, this in our home. Okay, so this is satellites. So radio wave from communication satellites are reflected by the parabolic dish and focused onto the antenna horn or the feed horn. So this is the antenna feed horn. So all the satellite, the signal from the satellite will focus here and then reflect to the by the disc go to the receiver. Okay, so this is the satellite. So the transmitted signals goes to the satellite and reflected goes to the antenna. Now we move on to the next application used in oil and gas exploration. Oil and natural gas trapped in the stone several kilometers under the surface of the earth. Okay, so patterns of reflected sound wave caused by different rocks enable the location, depth and structure of the seabed, which contain sources of natural gas to be identified. So here we have explosion. Okay, here, so the explosion will move here, go through down to the ground, and then will be reflected and received by the receiver here. Okay, the geophone and connected to the computer. So when there is oil here, so the reflected signal can be seen very low because it will not be reflected back because oil have a soft material, soft surface, right? Okay, next we have a deep sea exploration. The idea is the same. Okay, we have a sound wave transmit go to the ground here, and then it will be reflected and received by what we call hydrophone. Okay, transmitted of incident wave and received of the reflected wave. So ultrasonic wave is transmitted to the seabed. It is reflected and received by a receiver, and they can analyze the data that whether there is oil or not. Okay. Okay, lastly is we explain how the ultrasonic wave are used by the bed to detect the distance of the obstacle in front. So what we do is the bed emits ultrasonic wave. So bed emit ultrasonic wave, and the wave is reflected by the obstacle. The time between the emission and reception of the reflector is detected. Okay, from the emission goes to the obstacle, reflect goes to the bed again, so the time is detected, and the longer the time, the further the obstacle. So the bed can estimate the distance by estimating the time of the receiving signal. Okay, we can use the formula S equals to VT over 2. Okay, that's it for the topic 5.3, reflection of light. Reflection of wave. Thank you. See you again.